Hey guys, welcome back to the channel. I have another Marine ECM. Actually, it's from Florida too, and it's 4.3 Alpha. This is Joe Davila. He sent this computer a couple of days ago. Actually, I think I got it. I erased the number. I think it was yesterday. Yeah, today is Sunday. Yep. So I think I got it yesterday. I got a little delayed from the deliver, but it's finally here. So Joe has issues with the computer runs, the boat runs, or the engine runs, but it has like a hiccup. It's running and then it stalls, almost stalls and keeps going, and then he swapped it with another module. That's what he said, and it runs good. So I normally do with these computers, as I probably, if I have Guillermo's already up, you'll see that I always open it up to make sure there is no water here. So this is very a nice coincidence that we have two 4.3 alphas coming from Florida at the same time. All right, so Guillermo has not approved the repairs yet, so I have to move along, and now he's going to be on the bottom of the list. I'm sorry, but if you send a computer and I send you a request for approval and you don't approve, which is okay. I understand sometimes the shop needs to talk to the customer and so on. I hope that you understand that will put you in the bottom of the list, and I keep going with testing and repairing all the computers that are approved as I request, which is normal, right? So I hope that you also understand, if you're watching this video, that is very common, normal situations on business, right? We need to move quickly, because there is always people like, where is my computer? When are you going to test it? Can you repair it? So I need to be moving quickly. All right, so let's see what we find. So let me show you first, before we go into the test, a short video that he sent me. This is his computer, so he can see it. I have it open, and he will know that is his computer. Looking at the case, we can see no water, and which is good sign. Everything looks okay in there. This is a 2003 module. It's an ECM0402. Let me just make sure I'm saying that correctly. Yep, it's an ECM0402 4.3 Alpha Merc Cruiser. All right, let me take you over to that folder. Joe's folders right here. And yep, okay, perfect. Let's play this short video he's saying, and look at the almost at the middle of the video. It's like a 20-30 seconds long. There, almost died. Hopefully, I hope that the microphone picks up the situation, but I can definitely see the issue. I think that I don't like to see is the computer not bolted in, but it's a let's say a control test. You can see that he's running this out of a hose, so we'll see what kind of faults we get here. Let's try to see if we can connect to the computer. So I think for the easy of you to see and everything on all the cameras are captured, that I'm going to put it better if you're here. All right, I'm going to put the meter. All right, so let me see if I have everything in place as well here. Do I have the other diacom pit? Yep. All right, so let's power this up. I got the fuel pump prime. Perfect. All right, so the fuel pump prime showed up. Let's see if we can read faults. I am doing this live with you. I have not connected this computer before. So I'm going to do the connections, the normal, so Merc Cruiser. You can see the pictures of the computer that will use, because this is the diacom from Rinda, Windows base. You can do this on a laptop. That is another Merc Cruiser, but you can see the picture very different, right? So we're going to select this one, and it shows you also what connection you need on the boat. All right, so those are all my values. I want also to address or to show you my coolant temperature sensor is 172.4, and my air temperature is 75.2. So plus or minus 1 degree, let's say. The reason I'm telling you this is because the fault codes in the history, it has a freeze frame, and this is very unique to Diacom. You cannot see this with TechMate. When we see the freeze frame, I can locate those parameters and see if that fault happened here, because, I got not everything connected, right? but I want to make sure that I know which ones are here and which ones are in the boat. All right. So let's go over to the code. We're going to click on the H that will allow me to read the fault and the RPM history data. So that data is the one that we're going to collect, and I'm going to save it on his folder. So you'll see me probably a little bit doing that. That's something on my iPad. Actually, nothing is the mouse cursor. All right, so let me first save this. I save the file for him, the diagnostic data. Let's just scroll down to see how many hours we have first here. Oof, we have 1,190.17 hours. The only thing that shows us a full history is the horn output. A lot of hours on this module. And it looks like the hours were erased because looking at the RPM data that I see here, I would probably say that we have not even 600 hours of RPM history. So it was erased before. But let's see what we got. So what was the last one? So 90.17, 1190.17. So let's see. All right, this is definitely his. It says fuel pump delay circuit. And the reason I say it's his, look at the temperatures. That's where the blue line is. The manifold air temperature is 116. That's definitely not mine. And the coolant temperature, 147. This happens on the stall. The engine is stall. Let's see what values we got. Manifold pressure, 14. That's, like barometric pressure of Florida, pretty much. And it has 100% available power. So I cannot really go by anything in here. There is no fuel pump or C-pump pressure, but it's off, right? So let's say that is okay. Let's go on to the next one. Also his, based on the temperatures. EST1 open. So this is very, very, very good. Okay, that is his problem. EST1. Okay, there is only one EST on this motor, and that is the sensor signal that goes over from the distributor to the computer as a cam and crank sensor signals, and then the computer sends the EST signal out to control the ignition firing, because there is a small module inside the distributor that will fire the coil. So that is how this system works, and we'll see what we see, right? So because I have the oscilloscope connected right now into injector 1 and 2, or bank 1 and bank 2, 4 injectors per bank. But I will move it over to the ESC signal, which I have connected with my simulators, and everything is being injected. So we'll see how that works in here. All right, let's keep going up. I don't like the C pump pressure of 0, but he was having he was running this engine on a hose, and we can see that. So that pressure will not go up because it's very minimum water going through, right? Battery voltage, again, it's on the stall, so it's still considered okay. This is also his. Yeah, you can see the C pump circuit low. Right now, at least, the C pump is reading 9.97 PSI, so I guess he put more. This is Guillermo, so give me 1 second, guys. Hey, guys, sorry. That was actually Guillermo authorizing the repair. I tell him, I'm sorry, but I need to move. All right, so where were we? All right, so, okay, we were analyzing the data. Let me just see, and I have that video. I need to stop. Yeah, I closed the analysis. Let me just make sure I'm in the same page. Yeah, we got the C pump reading 9.9 and then reading nothing before. Well, let's see what we read, right? So the other thing that I want to show you is the test system information. So I'm going to disconnect the communication. This is, again, very unique to Diacom. You're going to be able to see because it's going to populate all the information from this module. So this is an 03 May calibration, Alpha 4.3. And the calibration number is A64270-6. So this is very important. I always save this data. So I copy it here. And I go over to the customer folder, which you're not going to see because I'm not in the capture. So let me just 1 second, because I add it. I always add this information to the folder, to the, let me make sure, where is it right here? As you see, I am a data analytic person, and I like to save all the information possible. So for the future, if you send a computer to repairs here on Mike Salazar Diagnostics, even if it's 5 years from now, I will have every single document and test that we did today. So I don't think any other company does. I have information for probably, I don't know, maybe right now, probably 15,000 repairs, everything with to the dot. Emails, conversations, payments, invoices, labels, everything. Computer, and that's what I like to. I do talk with persons, obviously, on the phone, but I like to have emails and text messages like that. If something changes or, oh, Mike, I never say that, I can send you the text. It's like, Guillermo, Joe, this is what you said. So it's okay if you want to take it back, but if I already send you the computer, this is not what I said. This is our conversation. Because, it's okay. Sometimes your memory can play like, you remember a different conversation that it actually happened. And I don't like to put words that were not there, especially when I'm trying to deal with a customer. I want to be always the more transparent possible, and that's what I do it that way. All right, so let's go back to the tests. Now we have the information that I need in here. So let's go back to the ECM and connect or reconnect, right? Because we were already there. I can close that. Well, actually, no, I don't need to close it. Let's just, actually, it's better if I close that because otherwise it's going to stay on the screen. Yeah. All right, let's see how it runs or if it runs, right? Well, actually, it does run. We have injection, 100% power, and I can see the EST signal there. And see if I read any or see anything abnormal here. Remember his conversation, it says from Joe that they plugged another computer and it ran good. Let me just make sure that I'm not, because I have two computers from the same model. It says, and I actually has his email. Just remember, that's what I like to revisit conversations, right? Hi, Mike. I saw a video of YouTube and I was wondering if you can shine some light. I have attached a photo of the ECM in a video, the one I just showed you. Then it starts and runs, but then it has a hiccup. When I switch computers, it runs perfectly. You see what I mean? So it seems like it's from this computer, and he did put another computer. So let's see if we can duplicate the concern here. That's what we're trying to do here, because right now, I don't see nothing abnormal. We got the firewall reference, as you can see, and I'm checking in there the firewall reference and the sensor ground. So my multimeter, the one you can see on the yellow letters, right there. A little hard to point on or imagine where to point, right? It's connected to the sensor ground and the sensor power. So if either one is missing, we will see a 0 reading or something in there, right? And the reason I do that is obviously to check and make sure that both are good. But yeah, we got 100% power running an idle, nothing abnormal. I don't see nothing bad in there. So let me move one of my leads. It's going to be the blue channel, the red channel. As you can see now, the red channel is no longer having a signal, it's just a flat line. I'm going to connect it to the EST signal. And we have it there. So let's see the amplitude of that waveform, because we can have a signal, but it's the correct signal. That should be, 4 volts. It's actually correct. It should be a 4 volts to, and it's actually 4 volts to half a volt. The other signal, which is the injector, you can see probably I have readings in there for the blue channel and the red channel. Blue channel is A, that's what Picoscope names it, and the red channel is B, but they're all looking normal. So the only thing I'm going to do is I'm going to leave this computer running. I'm going to pause the video and going to let it run for a while to see if it warms up, and then it shuts. Start losing that signal, because here is how you capture problems like this, right? So if you have a boat, a car, anything, right? You need to see, right? That's the way we humans are. We need to sense, right? So how can you know what is wrong on an engine or in a computer if you don't see it or feel it, right? So we need to see. That's what I use the oscilloscope. There is actually a very inexpensive oscilloscope, 2 channels. Look, all I'm using in here is a 2-channel, and I got 4-channel oscilloscope. But with 2 channels, I can put 1 channel onto the injector and 1 channel onto the ESC signal, right? And leave it on. And then on those handheld oscilloscopes like the Finercy, they're like less than $100. You will not be able to record, but you will be able to see. With Picoscope, I can leave this and go and have lunch and come back, and everything, all the recordings will be here. With the Finercy, you will be able to see. It cannot record. I don't know if it can record or not because I don't have that tool, but you can see it. So if you're looking at a screen, you will change the time base. Let's say, right now, my time base, which is the divisions, those lines, you can see it coming down, right, are divisions. So each of those lines represents 50 milliseconds per division. So we have a total of 400 milliseconds per screen. That is half a second. It's not really that much of a time, right? Because it's less than 1 second per screen. So if I go over to 100 milliseconds per screen, we can still see all those. We don't need detail, right? Because in this type of signal, there are some signals that you will be analyzing that you need to see the signature of the waveform. Let's say, when you're looking at an injector firing a GDI injector or so. But in this case, all we're looking for is to see if we miss one of the signals. So this far away is like a 1 second per screen. It will give you enough time to see if by any chance or any time on this capture, that red signal was missing, because now we can see how steady that red signal is. It's almost happening 3 times per blue space. So into blue and blue, let's say, every time the injector fires, right, we can see almost 3 of those red ones per in between that window, right? So let me just, I can move the red channel, sorry, the blue channel app. You see what I'm doing right now? So right now what I did is I'm using the injector signal closely, because let me make a zoom so you can watch this better of what I'm talking about. So I'm going to zoom into just this portion of the screen, maybe 2, right? So I'm just going to show you. So now I'm using the injector as a way to see if I miss a window of the ESC signal or not, and then the opposite at the same time, right? Because I can see 3 windows of the ESC in between the injection activation. You see how nice and easy it is to now capture if we miss one. So here and there, you're seeing that one gets shorted. That is the signature for cylinder number 1. That's very normal. So that is, it has to be there. But okay, so let me get out of the zoom. And now by putting the injector over the top of that, we will see if we're missing one of those ESC signals. And I don't see it. I can even go farther out. Now I can put it, let's say, 200 milliseconds. You see a little more choppy signal. The trigger cannot really pick up much because maybe, let me reposition that injector. Yeah, that trigger. The trigger is not able to stop it because now it's more capture. We're capturing around 2 seconds per screen. So now you see the signal being produced, right, as it goes. So we can go even into half a second or 1 second per division. Now I have 10 seconds per screen. And it's not that the signal is not being reproduced. It's recording as it happens. And this is what I usually do. I just leave it in here. And now I can have, I don't know, maybe because of the buffer saving time and the hard drive that I have in the computer, I don't know, maybe 64 captures or so. 1 second, guys. So what I'm going to do is I'm going to just pause the video, let this record in, and see if it fails. And I'll be right back. All right, guys. So it's been running for like around 20 minutes, and I have not seen a hiccup. So this is going to be a little hard to reproduce. Noticing he run it for like 15, 20 seconds, 30 seconds at the most. Not sure exactly what could be happening. Computer is now warm, which is normal, right? It's operating. So, but 5 reference is present and all the signals are present. So I'm going to move the capture now to the screen so we can analyze the data. So let me move you over to here. I'm going to take the rest out so we don't need nothing else. So, so I can capture 20 waveforms at the current level. I'm going to let that one finish. Now I'm going to stop it, and then we can go back and see if we see anything. And I don't see so far nothing. We can see the injection and the ESC signal all present. Just going, scrolling waveform to waveform to waveform. Right now we're in 3, 2, 1. So out of 20, not one time fell. And what it puzzles me is that he said that they put another computer and it ran good. So why is that happening here? It's a little bit of a hard to say. And he was running an idle. So I'm going to change the capture now to go closer. But right now we can see it's almost a stop in the screen just because we are in 100 milliseconds per division. I'm going to raise the idle. So let me get into here. Let's go up to 4,000 RPMs. That's going to make those captures more in the screen. That's what I also reduce the speed or the capture on the waveform. Now we're in 4,200 RPMs. I'm going to raise the throttle to around 40%. The rest I'm going to keep maybe the manifold air pressure, raise it up a little to put more stress into the computer. Now let's go back to the picoscope capture. And we can see now that the injection is happening more frequently, right? Because we are in 4,000 RPM. So I can reduce the speed now probably around 20 milliseconds per screen. You can see now the injector has widened itself due to the manifold air pressure. So now we don't get the 3 windows per injection activation because it's happening in a wider form. But we're now getting, that. But it's there. So nothing is missing. Everything looks normal. Yeah, I guess also like now the light on the IAC. Let me move you over to here. 1 second. You can see how the light now is brighter. Why? Because the IAC is now being commanded to probably 98%. And we can see that on here. If I move you over to the screen again, let me get a zoom glass. And yeah, so the IAC is now, the duty cycle is pretty much 100%. And we still get 100% power. So nothing is wrong in here. Putting those so you can see better from the distance. But yeah, everything is working as it's supposed to. I can put the meter back in the screen so we can see the 5-volt reference in there. And this will follow because if I go over to the picoscope, those captures stays there. But I don't see a problem. I'm going to change the time base on my captures on the oscilloscope to see more activations. But we can see the red, which is the ESC signal, completely good. So yeah, Joe, I don't know exactly what's happening with the computer in there, which is, I believe you, that you put another computer and run good. But this is not happening here. And this is what I can recommend to do a refresh in the computer, and it might correct the problem, but it might not. So this is where I don't like to ask a customer to spend any money on a module that I cannot duplicate the concern. If I can make it stop and fail, then I can reproduce it, even if it takes an hour. So I'm going to leave it in here for another 20 minutes of running at 1:35 p.m. and see if it fails. So I'll be right back, guys. All right, guys, still the same thing. No issues with the computer whatsoever. So yeah, I'm running it right now. Let me move you over to the screen capture. And you can see right now it's 2:05 p.m., almost 30 minutes of running, and it has not done one glitch, not one time. I have the scope connected, and you can see this is live data right now. You know, it's like if I remove the EST signal, you see it will disappear. You see right now it's not reading, and when I connect it, it's right there. So yep. So yeah, hi Joe. I am honestly at loss in here as far as reproducing your concern. As it is, I cannot say this computer has anything wrong. It's running perfectly. I have not seen one glitch in almost 1 hour of tests, and this is where I had to stop because I'm not sure what could possibly be, but it's definitely not in the computer. I respect that you said that you have that happening and you connected another computer and it ran good, but realistically, not sure what to advise you. We have 100% power, no issues, the EST signal, all the sensors, the fiber reference, everything is present. So in this kind of situations, all I can say is I find nothing wrong with the computer. All right, so I'm going to stop the video. This will be just a test, guys. So hopefully you understand what I'm trying to do here. And see that sometimes it's impossible to reproduce a problem. Trying to put the diagram in here so you can see it. Sometimes it's impossible to reproduce a concern. Is it something that is shorting inside the distributor? Not sure. It's just guess. It's because in here everything is fine, and I'm loading everything. I have injectors that I can put in here, and I have actually connected an injector, and it makes no difference. So the injector signals are clear, clean. Let me 1 second, guys. All right, guys, so what I decided to do is actually connect real injectors now. So I have 8 injectors right here. So hopefully you can see it's a little far, but I have 8 injectors going into a splice. It's a 4-to-1 and then 4-to-1 because we got only 2 drivers, like the way it is connected in the boat. So this is exactly the same way. Those are real injectors, and I have a voltage supplied on one side, and then the oscilloscope and the signals from the computer to command them on. So let's see how now this runs. I'm going to go over to here, connect to the computer, which I disconnected before. The computer is still on, but let me run it. Oh, before I do that, I need to adjust the channels because this is going to go high. So let me put them into 100 volts to see if it reads properly. And we can see the injectors in there. I'm going to put the RPM. I heard something weird in there. This one is firing. We can see sometimes something weird on the red channel. Going to change the speed so we can get more in the screen. You can see here and there like a double firing. You see that? Right there, it happened one time. Right there. So let me stop it. Oh, it just happened for a period of time. Let me turn the computer off 1 second, guys. So this is actually a good test. So let me move you over to the screen so you can see better here. Let me get the diagram out, pico, and the meter. All that glitter out of there. Can get this out. And let me get the order diagram out of the way. 1 second, guys. Yeah, this bit we don't need. And we can go back to here. So yeah, let me see. What is that? I'm glad that I did this because we can definitely see a glitch in here. You see it's like a double pulse. It happened only on the red channel that time, but we can see how also, you see that double pulse right here? And also see this white activation. This shouldn't be here. You see right here? This should not be here, neither this. Well, this one actually, yes. But you see the space in between? They should be almost spaced out the same. Let me go back into the rest of the capture. You see, you're looking about the same spacing in between the injectors. That has to be like that, right? It could be, it's only 8 injectors, so it could not fire more than that. Let me bring this down more so we can see it better on the screen. You can see how the maximum voltage went up to 56.7. That's what I raised the voltage capture. Let me go back into more captures. We have something on the end on this one. You see double right here. This on the blue channel and this on the red channel. Nothing on this capture. Once again on this one, now we're in waveform 7. We can see something on the red channel. I'm just moving the trigger. Sorry, guys. I'm like, why is not changing? Yeah, this one was clean. This one is right here. So we can see a little bit of that weird hiccup, right? This is the hiccup. Now I'm able to see it. So, this is very interesting. Very, very interesting. So it's happening on the injectors, not in the EST. What we have an EST signal, because remember, I was focusing myself on the EST more than anything. Let's see what is happening on the EST. I'm going to move. It's happening in both. So let me connect either channel onto the EST. And let's run this one more time. So let me run the computer. I need to make the red channel smaller. All right, so let me stop this. I'm going to stop the computer from running. Now let's go back to where that glitch happened. You see right here? So we can see something happening on the ESC at the same time. I'm going to gather these two. Let me move this channel up a little. Let me do it again. One more time, guys. I want to capture like before and after a little bit. So we have 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So the ESC didn't change. So it's not like that we have another activation on the EST, like firing the coils more. It's only happening on the injectors. You see that on the injector, it did. We should have one activation. And let me just show you the spacing between injection time, because this is very nice and controlled. We can see here. So the delta in between those two is 86.88 milliseconds. So the next 88 or 86.88 milliseconds should be around here. So we're very close. So that activation happened properly. And we can also see that in between the activations of the injectors, we got 3 EST signals. So that's also will help us see the difference or find where it should have fire. So the next one, which should be 88 or 87, right? Somewhere around here, right? So we should have 3 activations of EST and we only have 3. But look, we have now 2 activations of the injectors. That shouldn't have happened. That shouldn't have happened. And it's also a wider activation. So picking up this point, the next one, right? I'm going to go for another 88 or 86.7 or whatever, right? So let's say somewhere around here, that injector should have fired just only one more time, but we had 2 again. All right, so we're going to go over to another 88 or 86, which is around here, and we got 2 activations. So that is, again, no good. But then if we move from there to another 88 or so, that is the next one. So we only have 1 activation. So in between those 2 rulers, no activations of injectors, just the next one at that point. So those are happening in there for whatever reason, but it's not the computer. Well, let's say it's not that the EST is also having that signal. So this is very, very interesting. And the nice thing about it's a different computer, a different calibration, but I have another computer in here. Let me do that. Let me plug the other computer up. This is the same 4.3. It's an ECM0402 from a different customer. This is from Guillermo. So I'm just going to use it to use as a known good, right? Because that doesn't have that problem, and see how that runs with injectors. So I'm going to, well, there are different calibrations as far as years, because this is a 2005 calibration. This, I think, is 2003. So I'm going to have to power the computer off. You see that I lost the communication, which is okay. I'm just going to disconnect this one, and I'm going to keep it in here. I'm going to let you see what I'm doing. So I'm going to connect now the other computer. This is his, and I'm going to power or connect Guillermo's here. Now let's power this up. This one is working good. And we're going to do the same thing. So let's go over to this and let's run it, right? So we're going to remove all the lines in there, take the zoom out, and let's run this one at the same speed. See, that's how it should look. Well, we just got a little glitch in there. You see that? Because one thing that I want to make sure is my cam and crank correlation perfectly. This is where I don't want to, have try to repair something that is not there. Well, let me connect both backup injectors. So let me turn this off. I can see it a little here and there, but not as pronounced as it was with both banks. Let me check my connections in here. So give me 1 second. I checked the connections, and now both banks are plugged in there. Yeah, we see a little bit of that here and there. So this is where I don't want to fix what is not there, Because one thing that I also want to express is, yeah, the cam and crank correlation signals that I'm supplying in here might not be as perfect. In that way, that could cause something like this. That's what I want. Like, you know what? I have another computer in here. Let me connect that one. You see, because I can just hear that happening. I can put another channel to put a sync. Yeah, but that will make no difference. No, I cannot do a sync in here. Now with that, now with this, I would need to have a like a coil fire, and I don't have that here. Yeah, I think this is more the cam to crank correlation that I have here that is doing that. Let me plug his again. So let me stop these. I can turn the computer off. And I'm going to keep it running so you guys, run the capture so you can see me moving to the other computer. Again, this is from 05/27/2004, and this is from 09/04/2003. All right, let's run this one. I'm going to keep it at the same idle, same RPM. Not going to change anything. Actually, this one is less glitchy than Guillermo. It is happening, and they're here and there. Yeah, I think this is just an error on the cam sensor signal. Again, the correlation of the signals is very important. So that will tell the computer how many times to fire that injection, right? But injection itself, the activation is happening cleanly. Hopefully you can see what I'm talking about. We're here and there seeing double or so, but nothing. So I'm going to have to disregard that again. This is Joe's computer. Yeah, I can actually not see anything now. I checked the connectors and push everything really good as much as I could because those are temporary junctions that I'm trying to do. So I can reuse harnesses here and there, and I'm pushing really well this time. We can see here and there a glitch, but nothing that I will say is doing anything. That I think for me is again the cam to crank correlation signal. But nothing that I see a missing injection or something like that. He will not even feel this on the engine. No, guys, so, yep. I think I don't want to invest more time in this computer. Joe, I'm sorry, but I cannot duplicate your concern in here. So all I can do is test and tell you that here is passing the test. I cannot reproduce your concern. Without faults to go by. The only thing that I saw was the ESC signal, and I don't see any problems on that circuit at all. I'm going to again get a closer on the microscope view of the computer, but everything is working fine. IAC, injection, ESC signal. I cannot condemn this computer bad at all. All right, guys, I hope that you see the transparency of my tests. I don't share the repairs because obvious reasons. There's a lot of companies trying to copy what I do. And I'm not here to teach to move me away from the equation. Yes, I share the knowledge on how you can do the test. And if you're smart enough, you will pick up on what I'm doing as well as far as the repairs. But I am not here to teach you yet how to do what I do. This is, again, a test before and after if it's a repair necessary. But in this computer, I cannot recommend a repair. All right, guys, I'll see you next time. Bye-bye. All right, guys, I'm back. I'm actually, now able to reproduce it. So let me take you over to Diacom. I was about to stop the video, and I'm like, okay, so what is this? Let me take you over to Diacom. So he has not an overheating situation at all on the boat. So I want you to see the available power. So I'm going to get this here. This is 100% and it went into 6, right there, 6. Also, I want you to see the temperatures. And I actually can graph this too. So let me move this here. Because in a graph mode, we can be seeing this better. So we're going to put coolant temperature and available, and not the available power. Let's just pick up those two. This should be flat lines. Look at the available power going to 0. You see, now you can see a graph. Oh, I put those behind me so you can see the values. Yep. Yeah, but we can see the temperature going sometimes to 230. And now I can reproduce your concern. This is very, very interesting. This is pretty much the same problem he has. Remember the temperature going up to like 250. So this is what is creating the hunting or the hiccup that he calls, because he gets from 0, like almost 0 power, 6% power to 100%. And why is going from 100% to 6? Temperature. The coolant temperature is going to 240 degrees. That is overheating. See how important it is also to get a tool like this? Try to do this with TechMate. No way you can do it. At least I can graph in here. You can see the glitch happening on the available power and on the temperature. Look at that temperature sensor going from 170 to 230. I'm not touching anything. So why is this temperature going ballistic? So let's do one other test. I want to do this because this is very important for me as well. So I'm going to remove now the real injectors. And I'm going to plug this back in here. See, the computer is back running. Very important. See, without the load. And I can see also too is the amperage. I might want to do another test, and I'm going to use my bench power supply because the power supply from this simulator is not that strong. And I don't want to make sure, that I'm not providing the power to the injectors, and now that is creating an issue because it's not enough juice on this power supply. So right now you see without the injectors, the real injectors out of the equation, everything is perfect. I would not cut it. I'm glad I did that. Okay, let me do that. So what I need to do is I'm going to turn this off, and I need to share a ground. I need to turn this one on, and it just to connect the ground in between the two, right here. And I'm going to connect this power from here. Let me just see this. So now what I did is remove the injector load from there, and I'm actually getting power from here. But to do that, I need to put at least a ground in between the two, so the ground is the same. Otherwise, it would not work properly. All right, so what else I need to do? Ejectors are plugged in. Let's put the oscilloscope. Well, actually, I don't need to do the oscilloscope now. We can see it in there. So ejectors are running. You see, with this power, it's happening less. I'm glad I did that too. It's very important to find out if it's because of this is weak or because we have a problem on the board or in the computer itself. I still see a glitch on the voltage. Here and there, you see that? It goes from 176 to 190 temperature. The available power is less glitchy than before. You can see, oh, if I don't show you that, you cannot see it, right? So you can see now here and there the glitch, but never as it was before. And it's no longer going into 6%. The temperature is never raising up more than 190. Let me pause this, guys. I'll be right back. All right, guys. So what I do now is I'm actually going to put power from my power supply to that power supply to the computer to clean the signal, because I think this is more about a weak power supply on this simulator than anything else happening on the computer. But let's see. So I'm going to power this up again. All right. So let me get the diagram. That's all I think we need here, right? So let me get into that view to see what you guys are looking at. I'm going to make the diagram bigger. And that when we're seeing that graph, we can stay here. You can see, again, his computer connected. Ignition is on. Oh, let me connect to it. I don't need the oscilloscope for this now no more. The less loads, the better. All right, let's connect. I'm going to go over to graph mode. And we're going to select, again, the available power and the coolant. Let's select duty cycle of the IAC as well to see what that changed or not. And let's run it at idle. Lost the signal of the RPM, so I'm going to have to inject it again. It didn't like to me connecting it to the next supply. Give me 1 second to inject the signal. Come on. So yeah, when I'm pressing here, doesn't do anything. It's lost the sync of the cam and crank. Now the software doesn't want to open up. Sorry about that, guys. Close the program. Trying to restart the signal generator software. Okay, finally looked like it worked. Let me fix this, guys. I finally is accepting it. And let me power this one on. Running. Oh, I need to change the RPM. Right now it's like a 0 because I turned the whole thing off. I go around 650, 700 RPMs. I can go over the graph. Yeah, I don't see a change on the IAC, so I'm going to remove the IAC from there. Let me go available power, coolant temperature, engine speed. The bottom one is the engine speed. The center one is the coolant temperature, and it's only ranging from 167 to 183. And the upper section is the available power, which is now a steady 100%. So what is it telling me? Yes, the problem was the voltage supply. So my voltage supply on this does not like to have all the injectors and lot light in the computer. Not really sure how somebody can sell you a simulator with such a weak power supply. I would rather not have the power supply in there and let me buy a good power supply. And like I do with the Mark 50, I can connect this bench supply here. It's up to 50 amps. Really good power supply from Siglin. And I got another one in there that I use. It's up to 32 volts, 10 amps. And I like to use this one because it has a wider range and amplitude. Yeah, we can see up now in the power, it went from 100 to 90, and that is not abnormal. It could be a fault on the knock sensor, a fault on anything. The same thing again on the temperature. These computers are always a little glitchy, but that is a little glitchy. That is nothing that I would say, oh, this needs to be corrected. No, not at all. So, yep, again, guys, so sorry, false alarm. I thought I have it. I thought I'm like, oh, that is definitely a problem because if I'm going into, 200 degrees of temperature, 230 degrees of temperature and 6% of power, of course, 6% of power is going up and down, but that's not the case. But also, this is very important so you can understand how you need to analyze the data. Not just, okay, we got a glitch, we got to glitch what it is and keep throwing parts out of it. Parts are not going to fix anything. And I mean, you can be lucky and find the one by luck. You need to analyze the data. And what is the analysis of the data? This. I mean, you need to have a diagram where you can see graph. Again, remember what I was saying in the beginning? We're humans. We need to sense. That's what we got our senses, right? Hear, smell, taste. Yeah, that's the only way. So data, I can see that. I can tell you, yeah, this is okay. That I can live with it. It will not even be noticeable on the engine. So no, this is not a problem at all. And yep, Diacom Windows base is your best help. I don't know any other software besides the original that can do anything like that. There is a company, Jaltech or Jaltest, that tried to sell you for marine garbage. Don't even waste your money on it. I did that following some of the videos that I saw online from people that work in trucks, and it's all it has done in my business is a paperweight. I lost like, I don't know, like I think $11,000 or something like that. That I have never used. I used it one time for a material handler, and it wasn't even able to read it. So, and then for marine, I cannot even connect. And I proved them. You try to do a graph like this onto that tool, it will give you every 10 seconds. Every 10 seconds. Can you catch a glitch that happens in half a millisecond with 10 seconds? Of course not. So what is that? Garbage. And I proved it, and they refund me the money for, I think it was the marine software, and I should have returned the entire thing because I never use it. But it was my choice. I cannot blame them. But yeah, so if you're looking for any truck or so tool to work, don't buy Jaltest. I'm not really happy with the company. Not with the company, with the tool. The company was actually very responsive, very good people, but the tool itself, no good. I need a tool that I can use 100%. I use this all the time. I know how to use it, and I can learn any tool because I have multiple tools. You know that I have 20, 30 scanners. So technology is not a problem for me. Buying a tool is not a problem for me. I will analyze it, and I will use it 100%. And that's what you need to do, because I need to analyze data. I cannot guess. Guess is not part of my work. And this is where I would not guess to try to sell a repair that would not correct anything for Joe. All right, guys, thank you so much. And again, it was not what I thought it was, but at least hopefully it's so you guys see the problem that could be when you have a not good power. Because if this computer is not getting a good source of power in the boat, it will do that same problem, right? But look, with a clean power, with a clean ground, you don't get these problems. Okay? All right, guys. Talk to you later. Bye-bye.